Good morning, dear student. As on previous occasion, I had taught you about the various kinds of pressure energy. Now I am telling you about the Bernoulli's principle on the basis of these energy only. What does the Bernoulli's principle says? Bernoulli's principle states that the sum of pressure energy, kinetic energy, and potential energy per unit volume or per unit mass or per unit weight of an ideal fluid in a streamline irrotational flow remains constant along the streamline. It means if the flow is a streamline, the sum of all energy, that is pressure energy, kinetic energy and potential energy, should remain constant. You can take pressure energy per unit volume, so kinetic energy will be also per unit volume and potential energy will be also per unit volume, so that should remain constant. You can take per unit mass also, you can take per unit weight also here. So how to prove this Bernoulli's theorem? This I am telling to you. Suppose there is a cross section area which is varying cross section area, an ideal fluid is flowing through this varying cross section area is A1, here it is A2, velocity is V1, here it is V2, height from the surface is H1, it is how much? H2. So same way, continuity equation, that is A1 V1 is equal to A2 V2. This is called equation number 1. Change in kinetic energy. See, definitely, because velocity is changing, so kinetic energy will change. So change in kinetic energy of fluid, kinetic energy at point B minus kinetic energy at point A. Why B? Because here velocity will be more and here velocity will be less. So that's why kinetic energy at point B minus kinetic energy at point A. So this is the change in kinetic energy. Understood? So substituting the value of the mass. So I can substitute the mass here. A1 V1 T, mass is equal to volume into density. This is the volume into density. So this is using. So change in potential energy. So potential at B minus potential at A. M into G, H2 minus H1. So again mass is equal to volume into density. So I am substituting this value here. So this is another equation. So net work done, because see, work done and pressure energy. So work is done with the help of pressure energy. So pressure at point A minus pressure at point B. So that is called work done on the liquid. Substituting these value here, so this is the mass is equal to volume into density by the conservation of energy of the liquid. So change in kinetic energy plus change in potential energy, that should remain equal to net work done on the fluid. So this is the work done and this is change in potential energy and this is change in kinetic energy. So whatever work I am doing, that must be equal to change in potential and kinetic energy. Substituting all these value here, so this is work done and this is change in kinetic energy and this is change in potential energy, that must be equal. This is the equal sign. Dividing both side by a1 b1 and delta t, because a1 b1 delta t is a1 b1 delta t, a1 b1 delta t, that is coming same. So I'm dividing both side by this, and on simplifying this, it had become the pressure difference at A and B is equal to kinetic energy difference, and this is potential energy difference. Substituting these value, minus sign this side and minus sign this side and this minus sign this side. So that has become P1, V1, H1, P2, V2, H2 like this. So this is pressure energy at point A, kinetic energy, this is potential energy, that should remain constant. But only when fluid is ideal, this condition follows. So that's why we can say pressure energy per unit mass, pressure per unit weight, kinetic energy per unit weight, and potential energy per unit weight. That is also called potential head, kinetic head, and pressure head, that should remain constant. Thank you and have a great day. Next, we have to study about application of Bernoulli's